Hello, guys. Let's talk about how to determine empirical formulas from mass percent of elements. But before we jump into that, let's think about what is the meaning of mass percent. So we know that the human body is actually anywhere between 45 to 75% is water. So let's say that I drink a lot of water, so I'm probably well hydrated. I weigh around 140 pounds. So if 70% of my body is water, this means that I am walking around as 100 pounds of water. How crazy that is, right? So based on the mass percentage, I can calculate what is the mass of water in my body. The same way, if you know the mass percent of each element, you can calculate its mass in a molecule. So let's take a look at the practice problem. What is the empirical formula of a compound that contains 13.42% of hydrogen, 59.96% of carbon, and 26.62% of oxygen by mass? All right, now what is missing? Well, I don't know what is the overall weight of my molecules, right? Is it 10 grams, 100 grams, 15 grams? Well, let's make things easier and let's assume that I have 100 grams of this compound. So this means that if 13.42% of this compound is hydrogen, it is actually 13.42 grams of hydrogen. Okay, now if I know the grams of hydrogen, I can easily count the moles of hydrogen. And then if I know the moles, I can actually come up with how many atoms do I have in one formula unit. Let me show you exactly how. So since we have 100 grams, this means that 13.42 grams out of those 100 grams is actually hydrogen. Now, since I'm trying to figure out the empirical formula, I need to get to the number of atoms, hydrogen atoms in this formula. To do that, I need to connect the grams to moles. So let's calculate from grams the moles of hydrogen in this formula. To do that, we need to come up with a conversion. Since I'm converting grams into moles, I want to cancel out the grams of hydrogen and get the moles of hydrogen. So for that, I simply need to use the molar mass of hydrogen atoms. I know that 1 mole of hydrogen actually weighs 1.01 grams, right? Okay, so if you do this calculation, you are going to arrive to 13.29 mole of hydrogen, right? As the grams canceled out. Okay, let's do the same for carbon. So since we have 100 grams total, 59.96 grams of that is carbon, and then we can convert that into moles of carbon by putting the grams of carbon on the bottom and the mole of carbon on top. We know that 1 mole of carbon is actually 12.01 grams. Where am I getting these numbers? Simply from the periodic table, right? So you can always open up a periodic table and figure out what is the molar mass of each element. Now, if you do this calculation, you are going to see that this amount is 4.99 mole of carbon. Okay, so what's left? Oxygen, right? So if I have 100 grams, 26.62 grams of that is going to be oxygen atoms. And now I'm going to use the same conversion. Grams of oxygen go on the bottom. Mole of oxygen go on top. I know that in 1 mole, I have 16.00 grams of oxygen. So if you do this calculation, you are going to come to 1.66 mole of oxygen. All right, now I know the moles, but I don't know exactly how many atoms do I have in each formula unit. So how do I figure that out? Well, think about this. let's say I have water. Water is H2O, right? This means that I'm going to have for 1 mole of oxygen atoms, 2 mole of hydrogen atoms, right? So the ratio of oxygen to hydrogen is 1 to 2. And I am expressing it by not only the number of atoms in the formula unit, but also I can say 1 mole to 2 moles, right? So in this case, to figure out the empirical formula, I can take the mole ratios of these three elements. How do I do that? Well, I'm going to take the element that has the smallest number of moles, okay? Which one in this case has the smallest number of moles? Oxygen, right? And I'm going to calculate the ratio based on oxygen. So, for example, in case of hydrogen, if I want to calculate the mole ratio, I need to take the moles of hydrogen, which is 13.29 mole of hydrogen, and divide that by 1.66 mole of oxygen. So this is going to give me the ratio of hydrogen to oxygen atoms, or the moles of hydrogen atoms to the moles of oxygen atoms. It's exactly the same thing. Remember that moles work the same way as a dozen. They just represent a significantly larger amount of atoms or molecules or particles or bananas if you wish. Okay, so let's get back to this calculation. So if you do this calculation, you are going to get 8.00. So this means that in each formula unit for one oxygen atom, I'm going to have 8 hydrogen atoms. Okay, let's do the same thing with carbon. So in case of carbon, we have 4.99 moles, and oxygen is still 1.66 mole. So if you do this calculation, you are going to get 3.00. So the ratio of carbon to oxygen atoms is 3 to 1. Okay, why am I saying 1? Because if you do the same calculation for oxygen, you just take 1.66 mole divided by 1.66, so that's going to give you 1. So what is my empirical formula? My empirical formula is CHO, right? Those are the three elements. And if I have only one oxygen atom, I'm going to have 8 hydrogen atoms and 3 carbon atoms in this empirical formula. Okay, I hope this makes sense. See you in the next video.